design and inspection. Okay, in this section, we will talk about special situations. As you can see, there are many special situations and troubleshooting subjects within the ISA design and inspection manual. Due to the limited amount of time, only a few will be discussed in this presentation. So let's start with the cul-de-sacs. When paving a cul-de-sac, typically the paving equipment is too large and cannot navigate around the full radius of the circle. If the paver cannot navigate around the cul-de-sac, handwork will be required to cover the irregular areas prior to applying material to paver. Also, more cure time in the cul-de-sac may be needed to prevent damage from large vehicles such as garbage trucks, buses, and moving vans. Heavy vehicles, when turning in tight areas like cul-de-sacs, will apply higher stress to the pavement and could cause damage to the fresh material. So rolling may be required on projects closed to traffic, such as airports and parking lots. Rolling will provide compaction and help prevent loose stones from damaging foreign objects. If a roller is specified, a 10 to 12 ton pneumatic roller should be used. Steel drum rollers will bridge across high spots, crush larger stones, and leave scratch marks on the surface. Rolling should be done as soon as the mix is set enough to support the roller. Also use water with a small amount of detergent to wet the roller tires to prevent pickup. So when applying microsurfacing over rich, flushed, or bleeding asphalt surfaces, it's recommended to complete the repairs in cooler conditions. Because the pavement is slick, it can be difficult to achieve the specified application rate, because the rear strike off of the spreader box will wipe the micro from the surface. To correct this, a flexible rear strike off should be used rather than a rigid strike off. In some cases, a double application of micro may be required if the desired application rate cannot be achieved in a single application. So, okay, let's talk about troubleshooting. So as I said earlier, there's a lot of subjects listed in the troubleshooting section within the ISA designs and inspection manual. Over the next few slides, we will discuss a few problems associated with slurry treatments and use the troubleshooting process to determine the possible cause and how to prevent it from happening again. So there are 6 steps in the troubleshooting process. Identify the problem, establish theory or probable cause, establish a plan of action, implement the plan, verify full functionality, and document findings, actions, and outcomes. So the process of elimination. So pictured is a roadway with a non-uniform color. The color variations may not be noticeable until the next day. The discoloration usually disappears once the surface is exposed to traffic and elevated temperatures. These issues are typically aesthetic and shouldn't affect the material's performance. If the pavement is still non-uniform in color after several weeks, installing a fog seal will help correct the problem. So the problem is the road is non-uniform in color. So now let's take a look at the possible causes and how they plan to prevent them. So the first possible cause listed is the application equipment. It says it's non-accurately calibrated or mechanical issue affecting proportioning. Now the prevention plan says application equipment should be accurately calibrated and in good working condition. If multiple pieces of equipment are used on the project, they should be set up to produce an identical mixture within the job mix formula. The second cause is environmental condition. There's rain and recently applied material, cool temperatures or shaded areas, and variations in humidity. The prevention plan says slurry surfacing systems should not be applied if the pavement or air temperatures is below 50 degrees Fahrenheit and falling, or when rain is imminent, but may be applied when both pavement and air temperatures are above 45 degrees Fahrenheit and rising. So the third possible cause could be the emulsified asphalt. High emulsified dosages, additive and mineral filler dosages, and high water usages. So the plan says overly stable mixtures may lead to delayed curing and cause color variation, requiring reformulation of the emulsified asphalt or adjustments to the additive or mineral filler dosages. Adding excessive water to the mixture may cause the emulsified asphalt to migrate to the surface, giving a slick black appearance. Also, if the water is applied from a handheld hose onto the placed slurry surfacing, the emulsified asphalt may wash off the surface and expose the color of the aggregate. So this is another example of a pavement surface with a non-uniform color. So when the slurry or micro is exposed to rain before curing properly, the surface could show discoloration as pictured on the left. Two weeks later, after being exposed to traffic and higher temperature, the color is almost back to normal, as you can see here. So I said earlier, these issues are typically aesthetic and shouldn't affect the material's performance. So as illustrated in these pictures, the edge lines aren't uniform or aligned with the curb or shoulder. So let's review the next slides for possible causes and prevention. So some possible causes. So is the crew had difficulty following the edge line or curb line? The mixture contains an excessive amount of liquid. So the prevention plan says operate the spreader box and align the application equipment so that the edge does not vary more than 3 inches. Maintain accurate equipment calibration and adhere to the job mix formula and maintain the proper mix consistency necessary to produce straight edge lines. If the slurry mixture has too much liquid, material could flow out of the box, causing non-uniform edge lines. So in this picture, we see multiple tar tracks on the finished surface. So some possible causes. So occasionally a vehicle will drive across the slurry surfacing before it has gained adequate strength, leaving behind distinct tar tracks. The traffic control plan may not have adequate flaggers and devices necessary to prevent vehicle entry into the work zone. And the plan says, thoroughly review the traffic control plan to ensure no unauthorized vehicles can enter the work zone. Broadcast slurry surfacing aggregate on fresh material near active driveways or intersections to help eliminate any bonding of the slurry surfacing to vehicle tars. So in our last section, we'll talk about methods of measurement and pavement. So accuracy in quantity measurements is an essential part of inspection, and agreement of the quantities requires a coordinated effort between the inspector and the contractor. The contractor will specifically specify the methods of measurements and payments for the project. Methods vary among agencies, but usually fall into one of the following categories. So option 1, the unit area is measured in square yards, square meters, or square feet. So for this option, simply calculate the surface area of all treated pavements for the final quantities. So option 2 is tons of mix. which includes the weight of the dry aggregate, the mineral filler, and emulsion all combined. So let's review the steps on how to calculate the weight for each material, starting with the aggregate. So it says use calibration factors to calibrate dry aggregate used, or use certified belt scales to weigh the aggregate. Deduct the moisture in the aggregate to determine the weight of the dry aggregate. So for the mineral filler, it says use the calibration factor to calibrate the mineral filler used, or count the number of bags used. And then for the emulsion, it says determine the gallons of emulsified asphalt daily using the calibration factor. So then you add the aggregate, the mineral filler, and the emulsion together for the total mixed tons. So option 3, the tons of dry aggregate and the tons of emulsified asphalt are measured and paid for separately. Option 3 is calculated the same as option 2. So the inspector note reads, if the inspector would like to cross-check quantities calculated using the calibration factors, material usage amounts may be approximated by adding delivery ticket totals for each material minus remaining inventory. So the keys to success. So in both modules 1 and 2, we have learned the keys to constructing a high-quality slurry seal and microservicing projects. So let's review the keys to success. So it starts with proper site selection. Make sure that the pavement is a good candidate for the preservation treatment. It is important to not only have good specifications, but to enforce them. So early and final stages of the pavement preparation have to be completed properly. Matching the right equipment to the project is vital. So submitted mix designs needs to be accurate and approved by the agency. Contractor must perform an accurate calibration using project materials in the presence of the agency's representative prior to the project startup. So material consistency must be maintained through the end of the construction phase of the project. So the contractor performance is critical in the successful completion of the project. When performance standards are not met, work should be stopped until the contractor can exhibit acceptable workmanship. So equally as important as the contractor's role in the successful project outcome is the agency's representative, who must perform their role in verifying that the specifications are being met. So, and last but not least, information is powerful, and therefore agencies, contractors, manufacturers, material suppliers, and associations must continue to share the knowledge they have gained through experiences in an effort to better all aspects of the preservation industry. This is a quote from Jim Collins. It's as good as the enemy of great. So when we use slurry seal and microservicing best practices during the construction process and work together as a team, the end result is a high quality slurry seal or microservicing that we can all be proud of. So great color and texture. Nice straight edge lines and center joint. The striping looks great also. So here's some great resources to learn more about pavement preservation. So that concludes the slurry seal and the microservicing best practices. Thanks for listening and have a great day.